Turn the stream. Good. Starting. I got blah, blah, blah. So yeah, so what are we doing? We're gonna be working on Tungsten today. I want to start blocking out the logic for it. I really do want to get down and dirty with writing Tungsten. Like it's going to be very, like it's going to be very Lisp-y in nature, with like metaprogramming and other stuff. It's just going to be like the C equivalent to Lisp. Kind of. It's more in the sense that you can basically bend the language to your will, right? You can write Lisp. You can turn Lisp into any other language. Right? Because like Lisp isn't really a programming language in and of itself. It's more of a, just like a platform that you can write other languages. I want Tungsten to be spec forward, right? And much more of a specification, and less of a language as a whole. So I want it to be very easy to extend the functionality for the language itself. That's going to be something that might be a little bit more difficult to do. Because largely, like, I just need to figure out how to hot load new dynamic libraries, DLLs and things like that, so that I can build things like make it so that you can just add in DLLs and SOs. And it'll just like work, right? That's something that I think would be very nice, so that you can like load in like libraries and things like that for the actual like compiler itself. So, right? Because I think things like because I see things like language extensions, where you can create like posits or fixed point numbers and other things along those lines, or it's whatever else may come up in computer science that might need to be like a new kind of primitive that should be extendable, outside of the regulatory body of the original creator, aka me. Because I don't know how, I don't know if I'm going to maintain the shit. I have no idea. Going in and updating it here and there for newer versions, making it, I want it to be compile once and then the community can maintain it, right? I want this to be community maintainable. Because I'm only one person. I want to use it myself, right? But I also want other people to use it. I think that would be super cool if other people. So allowing other users to extend the language and release their extensions in a way that would be very easy to operate on and utilize and share is something that I feel is very important. So I think having some way of effectively, like, I don't know if I want to do something, is like the easy way of doing it, right, is that you have kind of like a manifest, right? Like a JSON or XML manifest, or some other similar, some such, right? You'd have a manifest of like packages and things that you can install on a compiler level, right? You build it into your version of the compiler. And you know, big bam boom, Bob's your uncle. Now, that is very nice for personal projects and things like that. However, it can be kind of a colossal pain in the ass for things like if you want to allow other people to work on your project, or if other people want to work on, or if other people want to fork projects, things like that, that becomes kind of a huge problem. And you know, these are all things that we're going to have to consider and look into and figure out the best way of handling. But I think for today, I want to go over some other stuff. Okay. So, what is it that we want Tungsten? Right. I mean, I guess we could also do. Notes dot mv. Because one of the things that we could do here is we could also say, you know, because we could also do something along the lines of, you know, Tungsten notes. We could do hello example. And then in here, what we could do is we could say, because like there's because I want to have aliasing, I would love to have macro. But the main thing is that I want aliasing. Because I want to allow people to pretty much just like alias their own shit. Right? Being able to call things whatever is most comfortable for them is important. Granted, like there's with great power comes great responsibility. Right? That's a very common thing. Like even with Lisp, is that, you know, Lisp has the power to turn it into a language much worse. You know, Lisp has the power to turn into a language much worse than Lisp, right? That kind of ideology and understanding is that is a very real thing that can absolutely happen. If you're not careful, because, you know, you can very much, like if you have a bunch of, you know, custom macros and things like that, like you can really ruin how things work, right? So the big thing is that you need to have the ability. You need to be able to support multi-file systems. right? Having monolithic file structures is really bad. So, let's say, take a look here. If you have something okay, cool. Right, so if we have right. So if we have okay. And what's this? Oh. Okay. Okay. So if we have what the hell was I talking about? What was I going on about? Yeah. The file structure. So we could have something like a whole thing, and then inside, you know, we have your different things. And here, I think C# kind of does it this way, right? Where you have right, where you just have your top level, you know, you just have your manifest, right? Which is you know, it's kind of like your BS proj, right? Your .cs proj. Because I think that handles your multi-file stuff. Right. So we could do something similar, which I don't think would be the worst thing, but I also really like the whole C++ part of things where you have like include, you know, using yada 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 and all that. And like same thing with C#. C# does the same thing. And just like the CS proj does, just kind of allows you to have access, right? There's also like the headers and linking the headers and cross-linking the headers and all that stuff, which is also very powerful. It might be a little bit better to have, you know, just everything that is inside of this file, everything that's inside of this folder structure, do it. But, you know, that might be, because usually what you have is like an entry point, right? And then there's also like cross references and cross linking stuff together, right? Because do we want, you know, because if we want to link these together, you know, we might say, you know, this It goes to here. This goes to here. This one goes to here. Right? Maybe this one goes to here. You know, all these are reliant on each other. This one might also be reliant directly on that. Alright, things like that. And with like C++, you have your pragma once. Right, which could get you into a heap of trouble, depending, you know. You also have, yeah, like there's just like a lot that's involved in a lot of this, right? So, you know, you could have that, yeah, it's this cross-linking is kind of a pain, because you can either have a manifest of where everything is, right? You could have like a master file, or you know, basically like file definitions that the compiler looks at for compilation. And then you just have like a main .w, right? And then this would be, you know, your entry. You could do that. Right, very similar to like project, you know, project.cs or app.cs or whatever the hell it is, you know, that you're working on. Right. So you could do that. So how do I want to do it? Because like a lot of the times what I'll do is that might be. I don't know if I want that. Because like one thing that I was thinking of is one thing was you could do your, you know, you have your main .w, right here, and then you have your and then you can have, you know, utils here, right? Okay. And then here, you know, you'd have math.w, I don't know, physics.w, right? And then here you'd have, you know, whatever. And then you could even have like another black sphere that, you know, does stuff. You know, another that has stuff. And basically what would happen is that anything that is in the, like this tree would be, anything here would be able to see anything below it. At, you know, this level and over, you'd be able to see. Right? So, so, you know, this guy here cannot see math.w. Oh, I don't like that. Because what you'd have to do is you'd have to symlink it. You'd have to link it somehow. Because you'd have to explicitly state, hey, this thing in here can look into this and see it. Right? Because the only other option is that you have it the other way around. Or you could always look up the chain. And if you want to specify things differently, then drop it into it. Right? You know, at the same level or higher up is the visibility, but I don't think I like that either. Right? Being able to see higher visibility. Yeah, because then, if we take on like object-oriented structures, and like visibility rules for that, that becomes a nightmare, right? So because there's also two different kinds of libraries. There's pre-built libraries and there's source libraries. Because like source libraries are really useful like especially for like small libraries where you don't need to worry about, you know, the overhead of you don't need to worry about the overhead. And those are much more like language extenders, right? And you see that a lot. You see it a little bit less in C++, but like even then, you have a lot of systems that are like headers only, right? And that is a type of source library, right? And that way you don't need to have a pre-built binary, you don't need to have, you know, a dynamic library or any of that stuff. I would also really like to have, like, there's a lot of things that I'd really like to have with Tungsten. Because I would really like to have a language that you can build like a dynamic library. And then it could like compile to source with dynamic library. Like compile the static from a dynamic library. That would be something that would be super fucking cool. But I have no idea if I could do that. Right? And that's largely with just how DLLs and SOs operate. Because those are like function pointers and things like that. So that's something that I would have to look into. See if it's even fucking possible. You know? Also, I have absolutely no fucking clue how long I'm gonna be streaming for today. I'm gonna try and go for a little bit longer, but there's no guarantee that I'm gonna be able to. With just like how I'm feeling and stuff. Yeah, there's just a lot going on. So, but yeah, because like I don't really know exactly how it is that I want to start with this project. Because like I have a lot of like there's a lot of like ideas rolling around up there, and a lot of things that are kind of, I don't know. It's really hard to say. Right? So let's move a little bit better. I don't want to do that and break my shit again. Fucking broke my tablet. I mean, it still works, obviously, but yeah. So let's go to another spot. Right? So one of the things that I want to do is have scope, right? So let's figure out like scope. And this is something that's going to be like really hard to reason about. Because if this is just a function, right? Because this can be your main function, right? Right. Like this is, you know, your int main, right? And in here, you know, we can have other functions like that. Alright. You have this kind of hierarchy of function scopes. And if any variable declared in a function dies at the end of the function, right? If you know, if the memory is freed at the end of the scope, then that guarantees memory safety, right? Because it would be super nice to think about everything being on stack, right? If you could treat everything as if it was on stack, right? If there was no heat, then it'd be super Gucci. But you also can't have it only be on the stack. That doesn't fucking exist. But I think you could have things like that be done. Because no matter what, like the creation and declaration of things will be right, you could, you know, declaring the existence of something and then populating it and stuff. Yeah, like doing the actual acquisition of resources might be a little bit difficult to do. Because it's also like, do I want to have a literal C like Lisp, right? Do I want Lisp but in C? But C like, right? Because I could do that. I could look into Lisp and it'll just be like, fucking write your own language, bitch. Right? Like, I could do that. You know, I could do the most most bullshit excuse of a thing ever. That's one way of doing it. I mean, and I still want to do my interactive novel. Right? Still want to do my interactive novel. Because I also have absolutely no idea what the hell happened to the interpreter that I wrote. Like, it's gone. It's fucking gone. Which is a bit of a shame. But oh, shit. Hello. Hello, Cosmo Game Dev. How you doing today? Fucking jump scared my ass. How is AMU? Huh? How's it going? I feel like it's probably going to my shit. Mobile dashboard. Yeah, 7 new followers in the last month. That's good. Sweet. Alright, so yeah, so basically, like, even if it's heat allocated and stuff, it should die at the end of the scope. Right? The only time that it'd be different is if it escapes a function. So what do I mean by that? A really good example of something like that would be if I go into here, then what I could do is I can say, hey, you know, int main, you know, well, so we could have a, you know, function, oh, add fucking int 32, or I32. What the fuck? Why is nothing highlighting properly? You know, C++. Okay. God damn. Fuck. Alright, so we can have int test. Alright. And in here. Yeah, I don't know why the fucking the shit's look like shit while I'm typing, but like it is what it is, I guess. God damn. Like I'm inhaling dust or something. Shit. Fuck. More coffee. It's probably the cause. This is an incredibly well seasoned cup. Blah, blah, blah. Okay. So the int test, you know, we have, you know, malloc, you know, big array, large, right? And then you have, I don't know, some kind of either, you know, fucking int, yeah, or some shit, right? You can have, you know, you do like a malloc of some shit like that, right? Because then, you know, you'd have like a malloc of like an int, you know, 1024. Malloc can for a big array, and you can return big array, right? You know, it's, what do you mean by bringing down CLI, no such file directory. Turning markdown lint. Interesting. I'll have to look into that. Message is, no, it's no string under cursor. Okay. And all this shit isn't working properly either, so that's cool. Well, oh, actually, I think, fucking, what is it? Mason install Markdown. Ox. What? Markup lint. Remark CLI. Oh, fuck my ass, dude. Markdown. Why markdown lint? Interesting. Markdown lint CLI 2. I mean, I could do that. NPM. Interesting. Okay, so. Four. Available. Let's see here. Install. Why? Is npm? Is it because I don't have npm? Did not find executable npm in path. Sudo. Because I feel like this is going to be the better way of doing things. No, this is gonna take a while. Alright, we'll just let that go in the background. So there's no situation where okay, so let's say so say we have Tungsten, right? And we have, we have some function, rep func args. Rep func args. I'm just saying return type function args, right? Because I want that to be the overall, syntax. But so say we have some function, right? And we have a var. We have a variable. Heap. Right. Var heap. Then here we do a free. Right. We know that if the void func right, var heap we have the we can dialog Alright. Alright, we can dial a heap, right? So, like, that's the thing. Because what we could do here is we can say, because we could do malloc, alloc. We could do an alloc of, you know, fucking, I don't know, int 2048 big, right? And this is effectively what we're doing, right? And then what we could do is we could say, you know, do stuff with big here. All right, we could do that, and then here we could say, you know, gallic big. We know that we can do this. Like, this is safe code. We know for a fact that you can effectively say at the end of this scope, destroy it, right? Destroy all the, you know, free up all the heap allocated stuff. That's just kind of, we know that we can do that because we understand that there is no way that you can, you know, you know that there's no, you can't use it afterwards because nothing can see it, right? Only everything within the scope can see this variable, and if that's the case, then, you know, everything else gets freed up anyway, right? This is effectively stack. So whenever you say, you know, create something big that goes into heap, you can also safely put in a, you know, you, in place, you say, you know, like when you put the variable onto the stack, instead of putting the variable on the stack, you put a pointer to the heap allocated stuff, right? In principle, right, you could do that. And then you put the deallocation there, right? So the scope doesn't declare where it's put. And I think that's an important distinction, right? So when is this a problem, right? When is this a problem? A problem occurs when you have right, when you have int reference. Right. Int ref, you know, big ref up here, and then in here, what we could do here, is say big ref is equal to big, right? And this is just passes the reference. Right. Right, it just passes the reference. So here what we need to do is we need to delete that. And then we can do a Dalek big ref here, right? Because in essence, everything is within one master, you know, thing. Because in essence, we just have one huge, alright, we could do something like that. Because we know that no matter what happens, there's always going to be this enormous, you know, thing here, right? This is always guaranteed. We know for a fact that this is a thing. Right, the entry point in each of these files is going to have their own scope and shit. Oh shit. Okay, yeah, because scope, because if we have the ideology that scope, the driving principle is scope declares lifespan. Right? So if scope declares lifespan, there can be situations where, you know, things go sideways. So do we want to have an allocation here, right? Because what if func is never called? What happens here? You deallocate a reference at the end of the scope, right? And like that's not very good, right? You know, so we're, you know, deallocating a reference that hasn't been initialized, that hasn't been populated, possibly. I mean, that could just be whatever, right? Because we're also not explicitly deallocating here. Right, this is an implicit call. We're just saying that the compiler automatically does this, right? So yeah, because we have like a malloc, dalek, you know. And like one thing that you can do is just say, like, how do we null these things? Because there's like, I want to have things be you know, I want to have these things be okay, cool, clear. Mason. Yeah, Mason. How do I... X. Here we go. So, how do I... Okay, so help. Uninstall package. Update. Update all outdated packages. Okay. Go. Yeah, okay. So we can say I mean I could just do that. Fuck it. Whatever. There might be some kind of fucking, I don't know, some bullshit going on there. Yeah, because like Mason does. Yeah, I forget. Oh right. I need to have. Yeah. I think. Yeah, I can. Oh, I didn't want that. Oh, shit. I wanted, I did that wrong. Right. So, I'll just take a look. Clang format. Bingo. I don't know what any of this shit means. This is the, Because I have resharper. Yeah. I have C sharper. But I want that. Right. Or I should say I don't want that. But I mean, I guess it is what it is, right? So anyway. The thing... So... So because we know that the big ref, it is always safe to like clear it up at the end, right? It'd be better if it was on last use, right? On whatever the guaranteed last use is. There's very few. I mean, having so because if that function is not guaranteed to run, if the function is not guaranteed to run, we know that this isn't necessarily a guaranteed. It's not a situation of guaranteed to be optimally free. It is guaranteed to be safe, right? This is a guarantee of memory safety. If you want to have more optimal freeing, then that is up to the programmer, right? That's up to the developer. Because, like, technically speaking, you would want to have a manual Dalek. You would want a manual Dalek whenever you, like, on your last use. Right. There could be ways of finding these, right? With like branch parsing and shit like that. So there may be, like, especially if it's like, say a variable isn't referenced, right? Say a variable is like created, used for a bit, and then isn't referenced again for the lifetime of the application, right? You can free it once it's done being referenced. At which point that's like compile time reference counting. Right, and you can do that. This also eliminates cycles. It eliminates memory issues with cyclic references. Because like this is like reference counting is really nice because it tends to free memory as soon as it can, right? It frees memory as soon as it can. But it can be very easy to but the problem with it is that it can be very easy to create memory leaks. Because if you have A referencing B and B referencing A, then it'll never let you have those resources. But here, no matter how you put it, they get freed. Right? So, this is a situation of it is guaranteed to free, and it's guaranteed to free safe. However, there is no guarantee about earliest available, right? You can set up, like with Tungsten, you would be able to set up your project to do that. I think allowing explicit, malloc and dalloc operators is, I think that's something that's very necessary. Because we could do things like declare, hey, we have this thing, right? And we might not necessarily want big ref. We might not necessarily want big ref. Because, like, why would why is that something that you'd want to do, right? Yeah. I don't know. I mean, and I still need to get back and fucking... I need to finish Kern. And I have a lot of other things that I need to figure out. I don't know how small I can make Kern with Lua. And I also don't know how small I can make it with C#. Right? One of the big reasons why I was being very attracted to C++ is that it compiles down into machine code very nicely. There is no runtime to package into it. With Lua and C# there is, right? It's the .NET runtime. So, in order to get all that up and running, I have to package in the runtime environment. And I have no control over the size, right? With C#, with C++, I was almost guaranteed that it would be the minimal. Right? Like, I would know for, like, almost like a stone cold fact that the runtime would be minimal. Because I'm writing the runtime, it's basically not existent, right? And that was really nice because that means I could make it so that you could share the executable directly over Discord, but especially with how Discord is going and how everyone is leaving Discord, that idea is kind of being thrown out the window. I don't know what kind of file transfer limits are for Matrix. I don't know what kind of file transfer limits are for Stout. Since Discord is kind of shooting themselves in the foot, I don't know if they're gonna recover. I don't know if that is an avenue that I'm going to pursue anymore. There's a lot of bullshit, digital rights and privacy violations going on. And it's a huge shame too. It fucking sucks. I absolutely despise it. I hate what's happening to the internet. A handful of greedy people are literally ruining it for the rest of us. And it's the end user that's getting, fucked 6 ways to Sunday because, the US government's gonna bail out their fucking daddies. They're corporate fucking leeches at the expense of literally everyone else in the fucking world, so, last time I checked, it was the government's job to be in service of its people, not fucking bend everyone over and just fuck them in the ass without leaning lube. So, I don't know. I'm absolutely just a bunch of rainbows and sunshine people. Yeah. I'm not jaded and bitter at all. Not at all. I don't know what you're talking about. Not jaded and bitter at all. Nope. Anyway, so back to Tungsten. So we know that Dalek is always... If there is a way to, like, if we know that, Big Ref is never, if we know for a fact that Big Ref is never used again, we could just deallocate it then, right? Because if there's no function calls that call upon it, if there's nothing that takes it in as a parameter, there is a way to trace, right? Like, all this shit is deterministic. There is a way to trace it. To a point, I'm guessing, right? And then you might be thinking, well, what about things like video games, where you need to hold on to objects for extended periods of time and shit like that. But in a lot of those cases, you have things like objects being stored in heap, because, say a physics simulation, right? Where you have a bunch of individual particles, and all of those are being put onto the heap. Because there's no way that you're going to store all that shit on the stack, right? That's just not going to happen. So what you do is you put them all into the heap. Sure, it's fucking slower than shit. Slower than fucking snail shit. But we have a lot of area, right? You have a large area to work with. You have a lot of available RAM in heap. And on Linux, you even have the ZRAM, and you also have swap. So, you know, and you can make swap as big as you fucking want. Like I'm probably gonna bump it all the way up to 16 gigs. To be honest. Cause get fucked. Yeah. So, like that's something to keep in mind. Like I don't know if Windows has swap. I don't think Windows has a swap partition. Like that's not like a thing that you can do. Hold on. Why is AI buying up a bunch of fucking RAM? When all you really need is an NVMe. And Linux. You just do compartmentalized I/O for the RAM, and you split up the No, I'm not gonna help the AI bros. Fucking if they want to be dumb, they can be dumb. Just use Linux and have a massive swap partition. You can have all the way up to like terabytes of fucking RAM. Many terabytes of RAM. Because it's just a fucking file system. Your RAM is a file system in Linux. That's why it's so easy to just have literally download more RAM. Like it's not even downloading more RAM. You just create more RAM out of fucking nothing. Because welcome to Linux. You can do that. I mean, I guess sure, because like hitting swap is really slow. But if you have NVMe, then you know if you have a solid state NVMe drive, it's not that much slower than hitting RAM. Like that's why we use solid state drives and NVMe's, right? That's why we have them. Is because they're so much faster to access. They degrade faster as well. That's why hard disk drives, HDDs, are, you know, more reliable long term. You have to swap out your NVMe's more regularly, right? You would have to essentially flash over the entire contents. And also Windows doesn't like it when you try and do that shit. Because go fuck yourself. But yeah. Yeah, I got another half hour in me. I could go for another half hour. Like, I'm mostly just trying to get 2 hours in at a time. Just to, you know, get things going, get things rolling. Alright. So, here we go. Yeah, so the ints ref big ref. We could do is being able to have the reference stuff. Having the reference stuff is really nice, right? Because like the thing that I'd want is what the fuck was I going on about? Okay, let's try that again. So we have the reference of a large reference. Okay, so within say like a game, you would, because like a lot of times you have like pooling and shit like that, where you're like mainly allocating and deallocating shit, right? Yada yada yada, blah blah blah. Because like I do want to write this, I want to write this language with game development in mind, right? Because I want to have, you know, destructive arrays as a first class citizen, right? Because like I want to do something along the lines of, you know, character, or like, you know, enemy, or like bullet, you know, 2048, right? I want to have something like that, right? Because like I want to have destructive arrays. Because, you know, because then, you know, because at this point what you have is that you have, you know, a pause, you know, 2048. Alright. Velocity 2048, right? You have all that stuff. And that makes doing certain operations very nice. If you set your order of operations properly, it can be very efficient. Because effectively what you do is you say, in physics, right? In physics, dt, right, in your void physics class, in your void physics function, what you have is bullets dot pause. Right. Because you have so so what you if you have a strict array of if you have a strict struct of arrays, then what you do is you have for pause in bullets.pause, right? Then you have, pause plus equals, well, I mean, for whatever, right? The val of, pause, right? Times dt, right? Conceptually, this is what you're doing, right? But right, this is conceptually what you're doing. When syntactically, for bullets and bullets, you do pause, bullet dot pause plus equals, bullet dot vel times dt. Right. You're doing all that stuff, right? And that just makes it a lot easier to cache and run through things a lot more efficiently if you're able to essentially just break up all that stuff, right? Because you could also do like all the X positions, all the Y positions, all the Z positions, and update all of those separately, right? Depending on your game, depending on how it's set up, all that shit, right? There is almost always going to be some level of bouncing back and forth, things like that. But it is in essence like a SIMD operation, because you can basically unzip all that, you can break all that stuff apart and like mesh it all back together again, in like a SIMD format, so that it's all like the same offsets too. Because since you know that it's all the same offsets, you can essentially cache all that stuff together. And there's other ways of doing it too. Like you can end up, like if you know for a fact that, like for you, and here's another thing about Tungsten that I want to do. I want to be able to create primitives and be able to construct things like structs and things like that at a very low level, like at the bare metal, like at the silicon level, right? So that you can say, hey, I want this particular object to have this particular memory layout. Because what you could do is you could say, for the bullets and stuff, like for these physics objects, you can package position x, position.x, velocity.x together. Because you're going to be updating your position by your velocity quite a bit, right? That's going to be happening all the fucking time. So you can load in those variables into the cache very fucking quickly, super easily. So you're not bouncing around memory all that much. You're just kind of trucking along in the order of which you need to do the operation, right? And being able to like spool all that stuff together and package the memory into that and into that exact layout can be a very, very powerful thing. And being able to just say, hey, being able to say like mem layout of, mem dash, layout mem layout of bullet is equal to pos.x eval.x pos.y eval.y, right? Because if you have these layouts like that, then you can do that. You can even say that like this is one unit. You can say like here's a unit that you do, and then in the struct of arrays and things like there's a lot of shit that you can do in order to have like how these things are drawn and shit, and like moved around and manipulated and all that, so that operations, so that operators are being called on the things as you need them while still being able to also being able to, at a high level, kind of, just deal with these things in a way that is very natural and intuitive, right? Because you can even say something along the lines of, say, hey, like what if we could do something like this, right? Right? Because what if we did something like this? And then this is a different block. Right? Because then this could be something like, color. Right? And we can also split all those things up, right? So that we can say, hey, if we're guaranteeing, like up here, this struct of arrays, this kind of mentality, this kind of unfolding, unrolling kind of situation. I want to manage it. I want to have this collection, this list of things, and I want you to operate on them at a high level. Right. I've declared the low-level management. I want to operate upon it at a high level. Right? Like that is the kind of things that I want to be able to allow developers to do. Because I just feel like I feel like that's something that's kind of lost in a lot of languages. Or just like not available in a lot of languages. And I still want to have this kind of, like, I want malloc, dalloc, nalloc. I mean, nalloc is a very memory unsafe situation. Because what I mean by that is, what is malloc? What is malloc? Big. Alright. What is this? Oh. So malloc is, right, malloc will cancel a deallocation. Right? It cancels the next deallocated for that variable. So like under the hood, it's probably going to be doing that when it's like unfolding and unfurling. Like when the compiler is like unrolling functions and things like that. That's probably what it's going to end up doing. Alright? Because like I really don't like the borrow checker. I don't like having solitary mutators on references and other shit like that. Like I fucking hate that shit. Like I'm not a fan of Rust. I really don't like Rust. I don't like the memory. I think it's incredibly clever. Very elegant solution to memory management. It's super nice, right? It is something that is very neat, very clever. I like that. Same thing with like garbage collector, right? The Java runtime garbage collector is something that's super cool. It allows you to just write code and not have to worry about if you're gonna fuck up your memory. And leave, dangling pointers and have, and just like trying to access shit that's not there. A bunch of problems that you can run into while dealing with C# or with C++, right? Like that is something, that a lot of C++ developers, especially like new, fresh C++ developers run into, or at least are made very much aware of, is that you can very easily just wreck shit, right? It can be incredibly easy to just fucking wreck your shit. Because C++ doesn't really fucking care, right? And you want to stay in debug for as much as possible until you have a fully functioning system without any bugs. Because C++ will absolutely go, hey, I'm just gonna, just start changing memory shit and just fuck up all your shit. Which, like, yeah, sure, there's arguments for being able to do that, and there are plenty of situations where that's actually useful, yada yada yada, blah blah blah. But for the most part, it's undesirable behavior. Right? The reason why C++ dominates at the right, like the reason why C++ dominates is because it allows you to do all that shit, right? There are very specific use cases for, doing the dumb shit. There is a use case for that. But like it's not, necessarily always something that you want to do. And I also like reference counting too. Like the idea of reference counting is super nice because it just, when you create something, it has, it increments its reference by 1. And then, like, every time it leaves scope or something like that, it decrements it. And then you can free it up then. Right. But if you have A referencing B and B referencing A, then it has 2, and then at the end of the scope, it has 1 each, and then it never reaches 0, and it never gets free. Right. So then you just have those kinds of issues. And I'm pretty sure that there's ways around that, of dealing with memory in a way that doesn't involve a rigid borrow checker or explicit reference counting at runtime, I should say. And like all these other kind of problems that you have with memory management. So my assumption is that you can manage these kinds of memory systems without dealing with all the same kind of bullshit. Right? Having this kind of deallocation being thrown up onto the stack and basically like canceling it out as necessary, because like basically what's happening is, you know, a lot of things just become kind of like aliases and shit like that, but the issue and it just gets populated up until the thing that uses it last, the thing with the highest scope, is what, because it's not the object itself that's in charge of the resources, it's the scope that is in charge of it, right? And you just pass the object up, you know, into the higher and higher scopes, the wider and wider scopes, until, you know, it's not necessary to bump it up anymore, right? So it is a bit of a middle ground, and you could absolutely do all kinds of other stuff. I think allowing for manual memory stuff is something that is incredibly powerful and should absolutely be a thing. Just be all like, hey, this is unsafe code. Alright? Like, if you are taking care of memory management, then if anything goes wrong, that shit's on you. Right? The training wheels are being pulled off. But what I want is for the language to be able to manage memory for like 99% of the use cases. The built-in memory manager should be fucking fine. Right? It should feel like you're doing things however the hell you feel like, and it just manages it for you. In a way that's very safe. Right, like I want, because I also have the idea of things like classes and things like that are much more, you know, like structs will be much closer to C# or C++ structs and classes. Very object oriented. You know, you break up how these things are structured, and I would want to have, you know, being able to declare the memory layout, right? Like this, right? Being able to do this would be such an unimaginably powerful fucking tool. Right? It would be absolutely insane. Being able to just say, hey, this is the memory layout, but this is how I want to address it. Alright. So that, you know, you are saying that you are grouping these things together so that this is one object. You know, saying, hey, this is just one fucking thing right here. This is another thing. Right? Because you could say, hey, instead of here, you know, we could also have a radius. Except the radius might be, you know, a completely separate thing. Right? You know, this might be, you know, a radius. Right? And then this could be, you know, a damage. This could be, you know, health. Right? And if you really want to get, you know, fucking crazy or whatever, you could even, I don't know, dictate. But I mean, like, this is all stuff that is like at the primitive level. Being able to declare all this stuff, being able to declare the memory layout of stuff. I mean, I could just do that. Have, like, I would want to have something that is explicitly a primitive. Right? Because I just feel like that is important to assert and maintain. But one thing is that I kind of need to I don't know why. This is not the thing that I wanted. And then I could do another thing here. You gotta be fucking shitting me. Cats, I don't have the stuff available. Because I want fucking something or another. Text. Manual. Yeah, okay. Yeah, that's close enough. Anyway, I'll be right back. Oh, what did I miss? Nothing? Of course not. Of course I missed nothing. Woo! Hooray for having no one. It's okay. What? Alright. So, let's go back to the scene and see how things are going. Alright, so what the hell was I talking about before I had to go use the bathroom? I mean, I don't know. Might just might just decide to end the stream here. Maybe, I don't know. It is what it is. Because I still don't know what kind of project I want to do. Because I kind of want to do a bunch of no progress beat bullshit. Because like I'm probably gonna be working on Tungsten off stream by day bits, and mostly just kind of going over changes for Tungsten. Actually, I think I'm gonna start doing that. I think I'm gonna start working on Tungsten off stream. And then when I start stream, I just kind of give an overview of Tungsten. Of like the changes and stuff. And then just kind of go from there. Right? Because I do want to do Tungsten. Right? I want to have this idea of being able to lay out memory. Right, being able to, you know, lay out the memory for different, you know, primitives and things like that. And objects and things along those natures. Because like optimal game design is a pretty difficult task to accomplish, right? Being able to write, you know, make games optimally. And what I mean by that is make games that are very performant can be a very difficult thing. And I want to make Tungsten a language where being able to do those optimizations and to write performant code is very easy and straightforward, right? Like that is my main thing that I want to do, is I want to have performant safe code 85% of the time. I want the language to do most of the heavy lifting, right? I want it to be so that you can build from the top down. Being able to build either, you know, use things. I want to be able to very easily take an idea, get it working, and then very easily break it down into smaller and smaller pieces to refine it more and more and more, right? An outside-in approach to design. So I want to have things like datums and behaviors and things like that. Because like a big design principle that I had was, you know, datum, you know, ints, count, you know, vec to position, right, things like that. These are all things that are kind of, right, like all these are various aspects, various things to keep in mind, stuff like that, right? So because like the whole thing is that I want to be able to, because like a class, because I want a class player who have datums, right? We'll have datums, right? Either datums or data, right? We'll have health, we'll have, position, we'll have velocity, we'll have, yaw, we'll have pitch, and we'll have, behaviors. Right, in here we'll have, physics, collision, raw. Alright, things like that, right? So these are all things that that matter and stuff like that. So there's a lot that goes into like how these things function that can be a little bit difficult to formulate. Because I want to be able to specify memory layout for the purposes of how, for the purposes of how they are packed into arrays or slices or whatever the hell it is that I want to call them, right? Because I also want to have like dynaries instead of vector, because I think vector is fucking stupid. Because we could also do like stacks. Well, I mean, a stack is something that's very, very specific. Because there's like a lot of really cool memory stuff that you can do. There's a lot of really nifty memory shit. A lot of memory finaggery bullshit that you can pull off, right? That's not necessarily easy to implement, right? Yeah, my temps are going up pretty high. Not super pleased about that. But yeah, no, I'm thinking I might, because like there's a lot of like how do I want this, right? Like how do I want this to be, right? How do I want? What kinds of things do I want this to look like? I want to, you know, because like I want to be able to. I don't necessarily want to have a separate, you know, because like I want people to be able to just start programming, you know, start typing and have things like immediate, you know, like an immediate response. Very rapid prototyping. I want rapid prototyping. I want rapid, you know, refinement. You know, I want people to. I want 80%. I want 20% of the work to get you 80% of the way there. Right? Kind of thing. Like, I want 20% of the time. I want 80% of the work to take 50% of the time. Kind of thing. Right? I want it to be very, very, very quick. I want rapid prototyping. I want rapid, you know, refinement. I want fast iterations. And I want it all to be safe, and I want it to be performant. You know, like, a lot of this sounds like, you know, a magic programming language that doesn't fucking exist. Like, will I succeed? Probably not. Right? There's a lot that goes into it, and I want to know what kind of, like, I'm trying to figure out how I want to actually pull the show, because the major part of it is that I want as much as possible to happen at the compiler level, because I want there to be because I want there to be, you know, extensions for the compiler. Right? I want as many of these libraries to be packaged into the shit stuff. Right? You know, things like SDL and other like graphics libraries and shit like that will be super nice if, you know, because having something like a Love 2D kind of situation, or monogame, or something along those lines, these, you know, basic immediate mode kind of graphics libraries, very nice, very convenient, right? Being able to draw these kinds of you know, primitive shapes and things like that is something that is super nice. It's very, very nice to have, and I want to be able to present all that stuff for, you know, I want to do a lot of things with Tungsten. I'm not entirely sure how I want to pull it off, because like I could test it out in Lisp, but I don't know what kind of like memory management shit that Lisp has, you know, because like a lot of this is how am I managing memory, right? How do I manage the heap? How do I manage the stack? Things like that. I also wonder if I should have, you know, a declarable stack size. Like, is that something that I want to do? Right? Like, should I allow people to declare how large the stack should be? And how does one go about doing that? Right? Like, how big should a stack be? a megabyte, 2 megabytes, you know, something like that. A whole ass gig. I mean, that's excessive. Don't fucking do that shit. That's a terrible idea. You know, do I want a definable stack size? Do I want, you know, these things? Because I kind of want this notion of being able to like a C-like language that can manipulate its own compiler, right? That way you can write your own dialects very easily. You can write your own, like, basically fucking everything in a way that's very, you know, clean and concise and shit. So I don't know. There's just like a lot involved with it that I don't know what kind of I don't know what kind of I just don't know what kind of progression and shit like I'll be able to pull off. So, I don't know. Anyway, I think I'm gonna be done. For today. Yeah, I think I'm gonna be done for today. I'm still kind of tired. I know that I need to eat, take care of stuff, do some things, think about what it is that I want to do. Like what? Because I want to define what control should the developer have? What kind of control do I want to allow for the developer? Right, like that is a question that I need to answer. So I'm gonna end it here.